All right, so this is the video key for review 4.1 to 4.3. We skipped numbers 3 and 4. I believe it should be skipped on your side of things, but I just want to let you guys know that we skipped 3 and 4. So let's look at problems 1 and 2. We're working with word problems. So everything I write, you should write. You don't have to write the word problem all the way out, but just remember anything that I write, you should write. So Julian has points for an MAC movie theaters. Man, I miss the movie theaters. He received 85 points for just signing up. He earned 3.5 points for each visit, and he needs 120 points for a free movie ticket. We're just writing an equation to represent how many visits Julian will need for a free movie ticket. So you can get 2 extra credit points if you solve the equations we find for 1 and 2 correctly. I know it doesn't seem like a lot, but the more of those little extra credit points you do, the more that's going to help you out at the end of the semester and end a quarter. So stuff we know. Well, we know he received 85 points for signing up. So sign up points, and I'm abbreviating points, we know is 85. We also know that he earns 3.5 points for each visit. So points per visit equals 3.5. And then we also know he needs 120 points for a free ticket. So points for free ticket equals 120. Now we need a variable here. We don't have one yet, but if you look at this statement, write an equation representing how many visits Julian will need for a free movie ticket. Right here, how many visits? That means we don't know how many visits we have. So we're going to have V stand for the number of visits. So now we're going to set up this equation using some wordy wordness. Now, what I like to do is figure out which one of these is my total, which one I'm trying to get everything else to equal to. Well, right here it even says, what will he need? Like, how many visits will he need for a free movie ticket? That's our total, right? So when I write this, I'm going to write my free tickets. And I'll write that on one side of the equation. It really doesn't matter which side, but whenever you write a total, it's by itself on a side of an equation, of an equal sign. So like this free tickets, that's what we're working towards. So that's why it's going to be by itself on one side. Now we have, so we've already used the free tickets. So now we have to figure out how to use the sign up points and points per visit. Well, so we have sign up. We have sign up points, and then we have the points per visit. Now, with these two, we have to figure out if we're adding them together, subtracting them together, multiplying them together, dividing them together. So let's say, for example, we roll up to MAC movie theaters. We sign up for this. So now we got 85 points. Then we are visiting, so they give us 3.5 points. Are we adding that to the total amount of points we have, or are we subtracting that, multiplying that, dividing that? We're adding that, so that's why we're going to use a plus sign. Okay, so some of these you're going to have to think intuitively. So now let's write out the numbers. So for sign up, we have 85, then we have this plus symbol, then we have 3.5 equals our free tickets, which is 120, but we still haven't used our variable yet, number of visits. Well, if I look at these 3 little phrases we wrote out, which one talks about visits? The points per visit does. So that's where I'm going to tack on my V. Okay, so that's where my variable goes. We wrote out the equation. That's all I've asked of you to do. Remember, if you solve for this and get it correct, you get extra credit. Number 2, a group of friends wants to go to Six Flags. They have $94 to spend on parking and admission. Parking is $14.75 and tickets cost $13.25 per person. Write an equation to determine the number of people who can go to Six Flags. Well, we know they have $94, so money to spend, $94.20. So we have money to spend equals $94.25. And it even says over here on parking and admission, we'll talk about that later. We know that parking is $14.75. And we know tickets cost $13.25 per person. So a ticket per person equals $13.25. Now we need a variable here. So write an equation to determine the number of people who can go to Six Flags. So we don't know the number of people. That's what we're trying to figure out. That's what we're trying to determine. So I'm going to use P for people, and I'm going to put number of people. I'm abbreviating that, number of people. Now, to figure out our total, so what I have squiggly lined under it in purple, we'll see how it says they have $94.25 to spend on parking and admission. So that's our total amount of money we can spend. So I'm going to write that as money to spend. And that goes by itself on one side of the equal sign because it's the total. They go by themselves. Now, it says we pay for parking and admission. This word and here is a nice little indicator that we're going to add the parking and the admission together, right? If you think about it, you pay for parking and then you pay for, going into Six Flags. You add those two things together. So let's write this out. So we got parking, and so that plus sign here, tickets per person. So let's write out the numbers for these. So since I already have red, I'll write my $13.25. Parking was $14.75. And then my total that we have to spend is $94.25. Well, hold up, wait a minute. We still haven't used our variable here, number of people. Well, which of these statements talk about people? The tickets per person. So that's where we're going to tack on our variable. So that's a way to think about it. Okay. All right, so we are skipping 3 and 4. It should be deleted on your end, and we're going to focus on some literal equations. Now, I know some of us have been struggling with the literals, so what's going to happen is the odd numbers will be regular equations. The even number will be literals where it's more variables, but you're going to have to use the same steps to solve the evens as you did the odds, and this will make sense in a second. So remember, when we're solving equations, you always want to check to make sure there's no group. And then if there is no group, or if there is, then we see if we add or subtract outside of the group first. If there's a group, if there's not a group, then you see if you can add or subtract, then you multiply, divide. So let's just get to it. So we have 2x minus 5 equals 11. We don't have a parenthesis, so there's no group, and there's no fraction bar that has a couple of things above it that makes something a group. So we have no groups here, so we don't have to worry about that. So that means we're going to focus on adding or subtracting first. So we see here, so we have 2x minus 5 equals 11. We see we're subtracting that 5, so we got to add that 5 to both sides. This gives us 2x is equal to 16. Now, this 2x, to get rid of it, it's being multiplied, right? Because there's that implied multiplication, right? Mathematicians don't like to write the multiplication sign down. So they just drop it, and they just write the variable and its coefficient next to each other to show you that it's being multiplied. So to do the opposite, we divide. X equals 8. And we're done. Now, with this literal equation, notice, so we have 2x minus y equals z, and this time they tell us to solve for x because there is more than one variable. They'll tell you which one to solve for. Now, what's happened is I went from this negative 5, and now I have a negative y. I have this 11 over here on the left side, and now I replaced it with a z. Nothing changes in the steps we take. All that changes is now we have a bunch of variables we have to work with. Okay? So if you added 5 to both sides to cancel out that minus 5, you're going to add y to both sides to cancel out that minus y. This leaves us with 2x equals. Now you're going to write it how you say it, and you're going to hear me say that about 6 billion times right now. Write it how you say it. So we have z plus y, so we write it as z plus y. A lot of us, for some reason, because we see the y is underneath when we add it, that doesn't mean that we have z over y. We didn't divide. The only time we should use a fraction bar is when we're dividing. If you didn't use it to cancel something out, you don't use it when you drop it down. So Now we have to get rid of that 2 that's in front of the x. Well, just like the one in number 5, we are going to divide. But when we divide using a literal, on the other side, we got to make sure we divide everything by 2. This leaves us with x is equal to z plus y all over 2. Write it how you say it. Up here would be z plus y all over 2. When we write it how we say it, z plus y all over 2. Number 14, again, I'm going to just keep this written on the side here so we remember. That's too many lines for the letter E. We have 14 equals 2x plus 26. So we're solving for x because it's the only variable we have. That's how we know that we're solving for x. Well, there's no group, so we don't have to worry about that. So now we just got to see, is there something we can add or subtract? Well, we're adding by 26, so we got to subtract that 26, right? Talking about that constant, if you remember that from way back when. This gives us negative 12 is equal to 2x. And for some reason, I really like the 2's today. So this 2x means 2 times x. To get rid of it, we divide by 2. This leaves us with negative 6 equals 8. Be careful. A lot of us like to drop that negative. Remember, if you have negative 12 divided by 2, it's still going to give you a negative answer. So be careful with that. Now, number 8 is a literal. We're going to solve for a. So just like over here, how we solved for x, we're going to do the same steps to solve for b. However, now my 14 has a c attached to it. And my 26 has a b attached to it. Doesn't change what we do to solve, right? So if we subtract this 26 for number 7 to get rid of it, we're going to subtract this 26b to get rid of it. You got to subtract the whole thing. This leaves us with, well, we have 14c minus 26b. Write it how you say it. 14c minus 26b. And we are left with equals 7a. Again, we didn't divide, so we're not going to write this. We are not going to write this as 14c over negative 26b. No, no, no. Okay, write it how you say it. Now we got to get rid of this 7 here. So just like the 2, it's being multiplied to that a. So to get rid of it, we got to divide 7 on both sides. But remember, when we divide with a literal equation, we have to divide the entire side of the right side. I'm sorry, the left side here. So we are left with this a. So now we have 14c minus 2b all over c. Write it how you say it. Or with dividing, you can just kind of copy and paste. That's kind of the nice thing about dividing. All over C. All right, looking at number 9. Again, I really like to have this available to me here. So I got to check if I have a group. Well, I sure do. This x minus 1 here is a group because all of that is being divided by 2. So we have to get rid of this 2 because we have a group. So remember, groups are when we have to kind of flip-flop the order. So that means we have to multiply or divide first, maybe. So to get rid of this 2, if everything's being divided by 2, to get rid of it, we're going to have to multiply by 2 on both sides. Those cancel. My group is by itself, so now it's just an x minus 1. 2 times negative 30 is negative 60. Now to get rid of that 1, well, it's subtracting, so I have to add 1 to both sides. Now be careful here, because negative 60 plus 1 is a negative 59. These are opposite signs, so you're like subtracting the numbers, but you can't forget that there's a negative. So just be careful with those signs. Watch your signs, watch your signs. Now we're going to do the same thing for number 10. We have negative 30 equals t minus u all over v. So just like how we solved for our x, we're going to solve for our t. That's what they ask us for. But now we've replaced that minus 1 with a minus u. We replace this 2 with a v. But we're going to do the same steps, okay? So to get rid of, so we have this group happening here. We have this group happening here. So we need to get this group by itself. Well, to do that, we got to get rid of this divided by v. So that means we multiply by v on both sides. This leaves us with t minus u. Well, negative v times negative 30, when you're multiplying a variable and a number, you just write it as negative 30v, okay? Now we have to add that u, just like how we added the 1 on number 9. This leaves us with t by itself. Now negative 30v plus u. Write it how you say it. Negative 30v plus u. And this is our final answer. Number 11 here. So again, I'm going to write out my, please excuse my dear Aunt Sally's, but in the reverse order. Do we have a group? Always check. Well, we sure do. We have x minus 4 as a group. So we have to figure out how to get rid of this 3. Well, this 3 is technically being multiplied to my group, but it's one of those implied multiplications where mathematicians drop the multiplication sign to be evil. So we have to divide by 3 on both sides. These cancel out. We can drop the parentheses, drop it like it's hot, because now the group is by itself. We have 12 over 3, which gives us 4. Now we're going to add 4 on both sides to get the x by itself, and we get x is equal to 8. Final answer. Now let's look at number 12. It's the literal version of number 11. Okay, we've replaced our x with a d. So we're going to solve for d, so we're going to use the same steps. We replaced our minus 4 with a minus e, and we replaced our 12 with an f. Okay, same steps though. So we see that we have a group within that parentheses, so we have to get rid of that 3 outside of the parentheses. Once again, we're going to divide both sides by 3. My d minus e is by itself now, so I can drop the parentheses. Then we have to do f over 3. Write it how you say it. F over 3 is written as, well, f over 3. Now we have to move this e. Well, if we added 4 for number 11, then we should add e to both sides. This leaves us with d is equal to, say it how you write it. No, write it how you say it. So we have f over 3 plus e. So we have f over 3 plus e. We are not adding that e just to the f up top. So this is going to be my no. We're not going to write this as f plus e all over 3. That's not what we said. We said f over 3 plus e. Write it how you say it. Okay? This e is being added to all of f over 3. And this is your final answer. Number 15, we're going to write an equation of the algebra tiles and then use words to explain how we solve. So we have 3 x's, 3 x tiles. We have 1, 2, 3, 4, 5, 6, 7 blue tiles. 7 positive blue tiles is equal to 5 negative red tiles. So writing this as an equation, we have 3 x's, so I'm going to write it as 3x. We have 7 positive blue tiles, so I'm going to write plus 7 equals. We have 5 negative red tiles, so I'm going to write negative 5. Now I want you to use words to explain this, to solve. So first step, well, we would subtract 7 on both sides, and I'm abbreviating on both sides. So we subtract 7 on both sides. We're left with 3x equals negative 12. Oh my goodness, Miss Rowell, if you don't know how to spell. Second step, so if this is what we're left with, we would have to divide by 3 on both sides. And when we do that, we're left with x equals negative 12 divided by 3 gives us a negative 4. Okay, you are going to have to know how to do this stuff, so please don't be using photo math. Please make sure you are trying and solving. All right, that's everything. Have a good day. Don't forget to turn this in before Wednesday, February 10th, before class.